Okay. First of all, once again, thanks everyone for joining the second session of the Troubleshooting Kubernetes deployment. And for those who don't know, my name is Adam, and I'm part of Wezva Technologies. So for those who haven't still subscribed, please subscribe to our channel, which is DevOps Learn Easy. So for those previous sessions that you have missed, or for any of the DevOps Essential videos, which is already there, so please make sure you subscribe to our channel. Now, just to give a quick recap on what was our agenda yesterday. So pretty much we were trying to understand what will be the life cycle of a pod, and in that, what are the different states, as well as how do we try to investigate what is the problem. So when we were going through that, so what we learned are the different phases of the pod, and we saw how the commands will be useful for us. And in that, first we pretty much saw how we debug a pending pod, and post that, we were trying to see when the pod gets moved from a pending state, that is, as soon as the pod is assigned in a particular machine, then the pod becomes a state called container creating. Now, in which what it does is tries to download the image from the registry, and it tries to create container out of it. So in that, the very first part what we saw is what are the issues that you might get with respect to invalid image name, or you have given invalid registry, or you do not have access to the registry. So that's when the pod will be in a particular state called image pull back off. Okay. Now, to continue on the same, now what will happen? Let's say Kubernetes or the pod was able to download the image specifically based on what you have given. However, after that, when it is trying to create a container, then at that time, there could be certain issues. Okay. Now, this is where before the container starts running your startup script or the CMD command, then what happens is the pod will basically check for all the volumes that is needed to create in the pod, and then it ensures that the volumes are mounted. Okay, so pretty much if you understand, once the image is downloaded inside the pod, what the pod will do is try to create the volumes and mount it. And only after the volumes have been created in the pod, it will be going ahead with creating the actual container. So this is when, now if you are trying to use the objects like config map or secret object in your pod to inject some kind of configuration files to your application, or it could be some kind of a certificate files, then what we need is we can mount the file from these objects, which is a config map or a secret, as a volume. So this is where, when you go back to the basics of config map and secret, one method where we can try to read the entire file which is available in the config map object or secret object is through mounting it as a volume. So now what happens is, there are some scenarios where you might have given a config map or a secret in your pod spec, but that particular config map has some issue. So in that way, what will happen? The pod will not be able to create a mount or mount a particular volume exactly based on these objects. So in those cases, under the container creation state, you will be seeing a error called as mount volume failed. Okay, so let's try to see how this looks like. Okay, so again, I'm going back to the same Minikube cluster that I have, just to quickly show you. So there's only one machine I have. Okay, so what I'll do, let me go to this folder, and in this, let's take this example. Okay, so now let me move a little bit here. So this is a pod spec in which I'm again using the same pod example, whatever we saw in the last session. So I have a pod called as test pod in which I'm trying to create a container based on Ubuntu, and I'll be just printing my name in a loop. Now in this, I'm trying to say there is a volume mount called test config map that should be mounted to a folder called temp config. So assuming that my application needs the file to be available under temp config. Now, what is that volume? So that is where you can see that I'm defining this test config map as an object which is the type called as config map. Okay, and the name of my object is my map. So pretty much what I'm trying to do now, when the pod is getting created, before the container creation, the pod will try to mount this config map, and from this, I'm trying to say, take a file called sample.conf. So if this config map object is available in the cluster, it will try to read or take this file and mount it as a volume inside the container under temp config. Okay, so this is where now, by any chance, if the cluster doesn't have this config map, or there is some problem accessing this config map or the file due to some network issue, then the pod will not be able to mount the volume. And in that case, once again, under the container creating phase, you will see that there is an error. All right. Now, before we apply this, I can quickly check whether do I have a config map available. Okay, so you can see there is a default config map available, but I do not have any config map object by the name my map. Okay, and this is what we needed, right? So in my spec, I am telling that I need to read a config map object called my map, and that is what I want to mount. Same way, if you have a secret also, I can take, but just to show you an example. Now in my cluster, I do not have any config map object by the name my map. So at this place, if I go ahead and apply, let's see what message we will get. So once again, before I run, what we will do, I'll take another screen. Okay, so this is what yesterday we had. So let's quickly connect to this machine. Okay, so I'll just say kubectl, get pods, watch. Guys, please go on mute. Okay, so here, let's run. So it would be monitoring. So now once I apply, you will be able to see the different phases. So let's go back to the first screen. Guys, please go on mute. Okay, so now let me go ahead and say kubectl apply. Okay, F and the YAML file. So here the pod gets assigned to a machine, and then it goes to the creating container stage. Now in this, it would have downloaded the image, but now to see the message, let's say kubectl describe pod, test pod, and I'm interested to get only the last few lines. So I'll just tail it. So here you can see that the pod clearly says that it's not able to find the object called mymap, and because of this, it is not able to do a volume mount inside the pod. So this is where even before creating the container, you can see okay, so what's happening here is before creating the container, it's trying to check whether the volume can be mounted inside the pod, which is where the config map object mymap is not available. So because of this, under the container creating phase, you can see the pod gives you message or a warning. And this is one of the type where when you get a message like this, then you need to debug and understand whether in your cluster, the particular object, which could be a config map or a secret, is it available or is it accessible or is it not corrupted? So you have to quickly validate it and fix it. So that way, anytime when you get a mount volume issue, it could be because of the config map object or a secret object that you're trying to put it inside a particular folder in container. Okay. Okay. Now, pretty much what we have seen is the mount volume failed. Okay. So this clearly indicates that there's a problem in accessing a config map object or a secret object, because both the config map and a secret object can be accessed inside your container by mounting it as a volume. All right. Now, once everything goes through, and the next phase of your pod is actually running, because now when the pod is able to successfully download the image, and if it has any volume, if that volume is also properly accessible, then what it will do is it will start the container. Okay, so once the container has been created and when the container gets started, the first thing that it will do is in your image, if you have specified a default startup command using the cmd instruction. So when you create a Docker file for generating the image, do you remember there will be a instruction called cmd. So using that, whatever the default startup command or a script you have given, so that will get executed. If not, sometimes even a user can give their own startup command. Like in all the examples of the pod, I have given a simple one-line shell script to keep running message or keep printing a message every 5 seconds or 10 seconds. So that way, now once the container is created, what will happen? The first command, which is the default command or whatever the user has given, so that command will be started to execute. Okay. Now, that's where what are the types of messages that you will get, or in case if there is an error. Okay. Now, sometimes even before executing the startup command or completing the execution of the startup command successfully, if there is a message, that's when we need to understand what are the different types. So one of the common or a famous error, I would say, which is crash loop backoff. Okay. Now this is where you will be seeing out of memory issues or there are some misconfigurations in your image. Okay. So now the pod has taken your image, and from that image, it is trying to run the default startup command or the command that you have given in your pod spec. So while it is running it in the container, you will see this error. So what do you mean by crash loop? So crash loop means, now if you understand, pod got assigned successfully in a machine, image got downloaded successfully, container got created successfully, but while running your startup command in the container, there is some issue. Now, because of that, what will happen? Now, in Kubernetes, every pod that you give, you will be having a condition in which if the container goes down, you can automatically restart the container. So when you're defining your image spec, you will be able to tell that if for any reason the container in the pod is going down, automatically you will be able to start it again. Now, because of that, what will happen is anytime if for whatever or various reason, if your container goes down, the pod will try to restart. So this is where under the pod spec, there is a keyword called restart policy. Now, because of that, what will happen? Now, if you understand the situation, pod got assigned, image got pulled, container created, and while container is running the startup command, there is some error. Because of that, container crashes. And once again, the pod will try to recreate the same container. And once again, it will try to run the same startup command. And again, it will fail. So that is where again and again, this process will be happening. And that is when it goes into a loop. So those kind of situations is what we call it as crash loop. That means the container gets created and the first command runs, and once again there will be the same problem, and once again container gets created, first command will run, and you will get error. So this is where when you get into the same kind of error again and again, then the error message what you will be getting is crash loop back off. Okay, now when do you get it, right? So there are two scenarios in which pretty much you will be able to see this kind of error. So one is out of memory. So what do you mean by out of memory? So when your pod is going to run the startup command or an application inside your container, and at that time, if there is no sufficient memory available for your container or the application to run inside the pod, you will see this message called out of memory. Okay, or there could be another way that your application is running, but while it is running, suddenly within the pod you will see there is no enough memory for the pod to allow the application to run in the container. So even at that case, the container will get stopped because the application inside your container will not have sufficient memory. So at those cases, you will be getting a out of memory issue, and whenever you get out of memory issue, the container will get stopped. As soon as the container gets stopped, because of the restart policy of the pod will try to recreate the container. So every time it recreates, there is no enough memory, container will fail. Immediately again, the container will get recreated. So that's where you will be going through a loop. So what you have to do in that case is, if it is out of memory, then you need to find whether there is no enough memory available in the machine or the cluster, or every pod, we know that there is a limit range or there is a resource quota inside the namespace. So you need to find out and make sure the pod gets enough memory so that the application can run inside it. Okay, so when you say memory increasing, you need to understand two things. Either on the machine level or the cluster level, you have to increase the memory. If not, sometimes you have limited your pod not to use certain amount of memory. So in that case, you need to find out within the namespace whether the resource quota has to be increased, or on the limit range, you have to see whether a pod needs more resource to be allocated. Okay, so that's the case where you need to increase the memory. But let's try to see how this error message looks. Okay. All right, now for this, let me go to another folder, which is runtime issues. And let's take this, okay? All right, now I have a small example here to show you to get this scenario. So what I'm doing, again, I'm trying to create a test pod, but this time, since I don't have an application which will fail, I just want to take a Linux image which has a utility called as stress. Okay, so usually this is used for doing some test and we can use the same. So what we will do now, using this stress image, we will run a command called stress. Okay, so what this will do, it will try to put load on the container. For that, I'm trying to tell, when I run the stress command, I need a minimum of 250 MB of RAM. Okay, so when this container gets started and when the first command runs, which is the stress command will try to utilize 250 MB of RAM inside the container. Okay, so that is what we are doing. But if you look here under the resources, I am trying to allow this particular container or the pod will allow maximum of 200 MB. So this is where in the resources, I'm telling the limit that the pod can maximum allow the container to run is 200 MB. So now because of that, what will happen? So when you apply this, the minimum requirement for the pod is 100 MB. So Kubernetes will see whether in your cluster any machine has 100 MB of RAM for the pod to get assigned, which is obviously there. Then the pod will get assigned. Then the next thing it will do is it will move to the container state. So in the container creation state, okay. Okay, I have to mute again, everyone. So once the pod has been assigned, we know that the image will get downloaded, which is where in the container creation state. Then the container will get created after the image download. So there is no error because it can download it from the public registry. And then it can also successfully create the container and run the first command. But while running the first command, we can see the pod has a maximum capacity of 200 MB, but your application or the startup command says it needs 250 MB. Now this is where the stress command inside the container, while it is running, it will not be receiving or it will not be having enough memory to run. So that is where during runtime of your command or the startup command, the container will get a message saying there is no memory, which is what out of memory is there. So immediately what will happen? The pod will stop the container and it will try to recreate the container because the container will exit. And as I said, for every pod spec in a container, there is a default keyword called restart policy.
I have one doubt. Sorry to disturb you.
Can you please wait until the end? We'll discuss.
Yeah, sure, sure.
Okay. So what will happen now is, here, if you see, this is a runtime issue because there is no problem in assigning the pod. There is no problem in downloading the image. There is no problem in creating the container. But while running your application or command inside the container, there is an error. And it is going to be a out of memory issue. And this will become a loop because again and again, it will try to run your container and the command will fail for the same message. Okay. So let's try to see this. Now again, let me go back to this. Let me run once again the kubectl get pods. And here, let me go ahead and say kubectl apply -f, and let's use the file name that we had. Okay, so okay, let's crash loop. Okay, so guys, there's some problem in the app. So because of the reason, I cannot mute everyone every time. But so please request everyone to go on mute. Okay. So let's see what is the message. So it says, while creating the pod, the minimum memory usage per container is 500, but request is 1. Okay, so this is because we have the limit range set. So quickly, let's see whether we have it. Kubectl get limit range. So yesterday when I was showing you this example, so we had a limit range applied. Okay, so that looks like it didn't get deleted properly. So just to describe this, okay, so you can see the limit range says minimum for every pod you should have is 500 MB, and that is where in this example the minimum I'm trying to take is 100, so it is not allowing. So to get the actual out of memory issue, let me quickly delete this. So what I'll do, kubectl delete limit range and the object name. Okay, so right now I do not have any limits. The only thing is within the pod we are trying to say the limit, which is where quickly to show you minimum for the pod is 100 and maximum is 200. So that's where I've removed the limit range which is applied to the namespace level. Okay, so now if I run, you should be getting the crash loop error. So let's go ahead and say kubectl apply, and you should now see that container is getting created, and in that you can see that it's giving you out of memory message or out of memory killed, and because of that it's going to redo the same thing again and again and again. Okay, so to watch what we can do quickly, I can say watch -n one kubectl, okay, and describe pod test pod, and I'll just stay. Okay, so side by side you should also see that what is happening. The pod is trying to create the container and then it's running the startup command, but while that command is running there is no enough memory available, so immediately the container gets stopped. Okay, and as soon as the container gets stopped, once again the pod will try to create a new container and then start it. So that is where you will be seeing that it keeps going into the loop, wherein it's clearly saying that it is out of memory error. Okay, so again and again it keeps running the same message. All right, so this is one type of issue where if during runtime, if your pod doesn't have enough memory, then you will be getting this loop error. So that the pod thinks that container is fine, but when the container is running, you will get this error, and you can see it just goes into a loop. Okay, so what should we do as a solution? Like I said, you need to first find out why this out of memory is coming. So does your pod doesn't have enough resources to give, then you have to increase the limit, or if the cluster itself doesn't have the enough resources needed for your application to run, then you have to increase the resource or the RAM on your cluster itself. Okay, so that's how you should be understanding. Now let me delete it. So this is one type of issue what I'm talking. However, there is another type of issue for which the same crash loop will happen, is a misconfiguration in image. Okay, so what do you mean by misconfiguration in image? Now, while you are doing a image generation, or technically what we call it as building an image. So what will you do? So you will write some Docker file, and using that you will be generating an image. Now in that application image that you're going to generate as part of your pipeline, that would be the CI/CD pipeline. Now what will happen? There is a base image from which you will be taking the existing layers, and on top of that you will be adding your build output, which could be a jar or a var, and all of them put together you will be generating a final image, and that is what you will be deploying using your pod spec. But what happens now, while you're generating your image, there could be some problem wherein the image is not perfect. Okay, so while creating the image, you might have missed some files, or you have given some wrong Docker file instructions. Because of that, image would have got created successfully, but the content of the image is not proper. Or let's say the jar or the var, what you have built, that itself has some issue. So in all those cases, there could be a problem with the entire image where image is not created properly. So even in those scenarios, what will happen? The Kubernetes will say, okay, I'm creating the pod successfully, and after that, I'm able to download the image, I'm able to create the container, but while you are starting the container with the startup command or the first command, then once again there will be some issues. Okay, so that's where now you need to first identify whether the image has been generated properly. Okay, now to understand this, I'll just quickly take a small example wherein now we don't have any application to show, but what I'll try to show you here is I'm going to take an image of Ubuntu to create a pod. Okay, now when you take a Ubuntu image, the default command that you will be running inside it is bin bash. Okay, so now try to understand, when you are trying to run a bin bash, or if you are trying to run a command which will be going through loop, so as long as the startup command is running, the container will also be running, which is the basics. But now in this example, if you see, all I'm going to do is just run a simple command called echo. Okay, now what will echo do? It will just print some message, and then it will complete its execution. So this is how as soon as the container starts sorry, am I audible to everyone?
Adam,
Yeah,
your
now you
voice
are
is
audible. Yeah,
Okay. Problem is, I think we need to mute everyone. Yeah, if I mute, I'm using the mobile phone to take the audio, so that also goes into mute. But anyway, just to repeat what I was saying, so understand this logic. Probably I'll put it up in the notepad. So again, this is the basic. So your pod gets created. Now the pod is going to create the container, and the container will run whatever the command you have. Now, as long as this command is running, or this could be a startup script or an application command. Now, as long as this is running, your container is considered running. But when I give a simple command like echo, then what will happen? So the echo command will immediately get over. Now, as soon as it get over, what will happen? There is nothing else to run. Then the container is going to be stopped, because the basics of container is, if you do not have anything in it as a process, it will get stopped. But now, as soon as the container gets stopped, what will pod do? Pod will try to restart. So that is where, in this scenario, if you see, pod will start the container will run the echo command, and once again container will get stopped. Again pod will try to restart. So this way your pod will go into the crash loop method. The same way, now, like I said, if you have generated an image in which the image doesn't have proper application in it, or some configuration file has been missed, or you have given a wrong startup script, something is problem with the application. So every time when the application doesn't run, the container will get stopped and immediately pod will try to restart. But every time the same problem will happen. So that is when, to debug this, you need to see what is the logs that you are getting, and for that you will be using the kubectl logs. And in case if you find out there is a problem, this is where, as part of your CI/CD pipeline, you are not going to just create an image and push it to registry. So you will be doing a step called as smoke test. Okay, so smoke test is nothing but a quick test where you will validate whether the image you have generated is good, and only then you will be going to the deployment, or you will be going to the QA, and you will be doing deployment or production and deployment. Okay, so if you go back to our classes, this is what we were talking. So as soon as you generate the image as part of your CI/CD pipeline, you do a quick test, which is called as a sanity test or a smoke test, and find out whether you are able to create a container and your application is running. Okay, so to get this message, this is the example what I'm using, where when I say in the Ubuntu, if you say echo hello, immediately it will get over, right? Nothing will be running. So that is the reason it will go into a loop. So let's try to apply this. Kubectl apply -f, and I'll just take this image as configuration. So quickly, let me go back to the other screen here. So you can see now what is happening. So it says container creating stage, and then it says completed, but immediately it goes back into crash loop backup, because pod thinks container is fine, but as soon as the container runs, what is happening? The startup command is completed. Because of that, the state of the pod is also completed, but immediately pod will try to restart the container. So once again, container will get created, and then the first command will get stopped, and then it goes into exited state, and pod will try to restart. So that's where pod will be retry to start your container again and again. Okay, so this is another issue that you will be going through. So once again, here you have to do two things. One is you need to do kubectl logs, okay, and you need to try to see what is the output that you are getting from the application or the container. Because why is it going in a crash loop method, or why is it looping by saying it's failing again and again? So to identify, first you should say kubectl logs. Okay. Now, sometimes what will happen is, when the pod is getting into a crash loop method, it would be very fast. For example, if you see it, just in a matter of second, the container gets stopped and pod is going with a crash loop. Now, for these kind of scenarios, if you just say kubectl logs, the container also might not have the logs. Okay, so that is where in the logs command, what you can do, you can add an option called previous. Okay, so this is again a useful option. Now, what is it needed for? In case if there is a container which was previously used, the logs will be stored. So right now I have a log, so it is getting it. But in some scenarios, your kubectl logs will also be not showing anything. So in that case, if there was any container before this, it was stopped and it had some data, you will be able to get it. Okay. Again, might an interview question, some might ask you, okay, when it goes into a crash, how will you even find out the log? So simply you can say, if any of the container had a log, by using -previous, you will be able to get that. If not, the kubectl logs will always show you the live container. Okay. Now, this place, if I go back again and if I try to say kubectl describe, and let's say pod and test pod, and I'll just take the last few lines. So I'll just tail it. Okay, so you can see this message again. So what is happening? The pod keeps trying to restart the container. Okay, so it runs again, it fails. So once again, it will try to create the container, start the container, it will fail. So these are the scenarios where if you get a crash loop error, then immediately you have to do two things. First, see from your kubectl describe command, which is again a useful command to find out why it is going through the loop. And second, now just by looking at it, if it was out of memory, okay, it was very useful. But in this scenario, if you see, it's not even giving out of memory. Then how do I find out? So this is where you should think, okay, the problem here is the container is running, but the container is getting restarted again and again. So why is that? Then you should be going to the kubectl logs and find out if the container has some error in starting the application. Okay, so in that case, immediately you will be able to see. And if you do not get a log, then you can say kubectl logs -- previous, then it will try to pull it from the previous log, whatever it had. So that's how you will be able to find out that, okay, because of this reason, my container is failing or my application failed for some reason. And because of that, the pod is trying to recreate the container. Okay, so that's how these are the two scenarios in which the container will be recreated again and again. Okay. Now, other than this, we also have another type of error during runtime, which is called as run container error. Okay. So pretty much when you will be getting this. So now pay attention once again. So let's assume now your startup command is not giving any error. Okay, everything is perfect. So now what will happen? The container will be continuously running and pod will not do anything. Then immediately the state of your pod, if you see, it will be in running mode. Okay. However, when your pod is in a running mode, it doesn't mean that the application inside the container is working fine, because your application might not be running perfectly. So this is where in Kubernetes, if you know the basics, so we have what we call it as a health check. Okay, so for every pod that you are going to deploy, there will be a health check that you have to tell, which will help us to find out whether the pod and the container inside it is running fine. Because just by looking at the state of the pod, you cannot say whether your application is running fine. Okay, now this is where we will be putting some health check. Now, the health check has to be written in such a way that it tries to go inside the container and it finds out whether your application is really working fine or not. And the basics of your health check is you will be giving it as a command or a script or a port number that you want to check inside the container and how frequently you want to check. So Kubernetes will go inside each and every pod replica and it will try to run that command. And in case if that health check command or script returns 0, then the container is considered it is healthy or application is running fine. In case that command returns a non-zero, then it is considered by the pod that the application or the container is not healthy, and then Kubernetes will try to recreate your container once again. So that is where now when you are deploying, you need to write a health check which will help you to capture whether your application is running fine or not. So what I'm trying to tell now is assume sometimes your health check is failing. Okay, so the pod was running fine, but suddenly because of some reason the application might not run properly and the health check command, whatever that you are running, that is returning a non-zero value. So when it returns a non-zero value, then Kubernetes will immediately say that, okay, I am receiving a non-zero value from this health check command or script. Now, if that is the case, it will try to retry minimum of 3 times. If all the 3 times it is getting a non-zero value from that command or script, then immediately the pod will try to recreate the container because the container will be marked as unhealthy. So this is another situation where while your pod is running fine in a running state, there might be an issue which is being given by health check. Okay, so that's where let's have a scenario to find out how that looks. Now, to do this, let me go back and delete this pod first. Okay, so I'm just going to take this example called health check. Okay, so just pay attention on what I'm doing here. So here I have the same pod in which I'm just running this command called echo for every 10 seconds. So as long as the script is running, my container is considered fine. But I'm trying to add a health check of the type liveness probe. Okay, and here I'm giving a simple command called ls and this file. Okay, because I don't have an application, so I'm just trying to run this. So what will happen now? Kubernetes will try to run this command as a health check command every 5 seconds. Okay, so what will happen now? Every 5 seconds, it will go inside the container and it will try to run this command called ls this file. Now, if this file is available inside the container, this will get a 0 return state. That means container is fine. If it gets a non-zero value, then the Kubernetes will think the container is not healthy and it will try to restart it. Okay, so to show you that there is a failure scenario, I'm giving it because there is no such file called temp test file inside this container. So if you just look at this, if I do something like this, you will not get a return status 0. So how do I find out the return status? Echo $? So you can see this is returning a non-zero. So this is how inside the container the pod would be running this command. Okay, so every 5 seconds it will run, but as soon as you run, in my case I'm giving a scenario in such a way that it will purposely fail because container is running fine, but you can see this file is not available. Because of that, the liveness probe check will return non-zero. Because it is going to return non-zero, the pod will think that the container is not healthy and it will try to restart. So this is where if your health check is failing, then once again to debug this, you need to do a kubectl logs and find out is there any error on your application console output. So that is where the application log is very important. So if you have a separate log file, you can get that, or you need to make sure by saying kubectl logs, find out is there any output on the container console log. Okay, so that is how you will be able to find it out. So to run this, what we will do once again, I'll just say kubectl apply -f, okay, and health check error. So it says pod is created, but if I go back this side, okay, so now you can see the pod has moved to a running state. This is because your container has been created and it has also started, and inside the container there is a small shell script which is running fine. Okay, so if I just come here and say kubectl logs -f and the pod name, you can see it's just going to keep printing my name. But now in a matter of 5 seconds, every 5 seconds our health check script will run, and when it is going to return a non-zero, then the pod will try to recreate the containers. Okay, so you can see what happened. Automatically it came out. Why? The container got stopped. See, container is running, but At the 5th second, when the health check is going to run, automatically it is going to return a non-zero because that file is not available. Then the container will be forcibly stopped and recreated. And that's the reason you will see this logs also comes out because the container is getting stopped. Okay. In fact, if you quickly see this side, you can see that this gets terminated and then you again try to go. So that is where you can see it goes again running and the pod recreates the container. To cross check that also, here once again you can simply say this watch command and we will try to see the output. Okay, so I'll just take the same command. So you can see now it clearly says the container got created successfully. While it is running, the liveness probe failed because there is no such file called temp test file. Now, because of that, it's going into the exit mode and immediately you can see the container has been recreated by the pod. When after comes up, once again, you will see that the health check is going to fail at some time. So that is where whenever you see this error, then immediately you should do a kubectl logs and find out why the application has failed. Okay, so because this clearly indicates that whatever the health check you have given is not working fine. That means your application is not working fine, which is 100% proved. So you need to find out by looking into the logs why the application didn't run. Okay, so there could be various reasons for that. Once again, it could be some kind of resource issue, or there was some network issue, or your application was not able to connect to database. Okay, so there could be various issues, but it clearly indicates that the application at some time was not working fine. Okay, but if it is failing in the beginning itself, then it also clearly indicates that the application startup itself is failed. So then for this, once again, you should capture all these kind of issues in your smoke test or your sanity. So which is where as part of your CI/CD pipeline, it is very important that as soon as you generate your image, it's not just simply right, you create a Docker file, generate an image and push to registry. Before you do, if you recall, as part of DevSecOps, we will be doing a scanning of the image and find out if there is a vulnerability. Along with it, we should immediately do a small smoke test in which you will try to create the container and check whether everything is fine. Okay, so that's when you will be able to fix this later. But there could be some scenarios where your application was running fine, but suddenly it will get restarted. Then there will be questions where you need to find out why it got restarted. So to know that, if you look at the logs and if you get something like this, then it clearly indicates that, okay, at some time the health check didn't run. So that means the container was not able to run the application properly. Then you have to go back once again by checking the logs and see if there is a problem. Okay, so this is another type of runtime error. Okay, so remember, it all depends on what is the type of error. And now if you understand, when you're trying to define your pod spec, it is not just that you will say a pod and a container. So what and all do we need? So you need a health check script, you need to specify your config map or secret object, you will also have your volume specification like persistent volume, you will have your resource quota. All these things is needed for you to know. So that's where when you go to an interview, when you try to explain something, it's not just to say that, oh, I wrote a manifest file in which all you will tell is I created a pod and for that I have given a container spec. No, you need to give end to end because all these things are needed for your pod to get deployed. Okay. Anyway, so the focus here was in case if there is any application startup issue or health check failure, even for those cases during your container runtime, you will be getting an error. So that is how you should be finding it and you should be able to debug. Okay. Now, pretty much we were trying to see some kind of errors, but these are not the only ones, because this is where there is another most important thing that we need to know is the life cycle of a pod. Now, what is that we have seen so far? So what we are seeing is different phases of a pod, how it gets created, how it gets deleted. But still, how does the pod behaves? Now, for that, there is a different conditions in every pod. Okay, because if you say kubectl describe, what I was showing you so far is the events, which is what we have seen in the end. But there is something else called as a condition in a pod. Okay, so now sometimes when your application is not running or you're not able to find your error properly, then you also have to look into the pod condition, which is where we need to understand how does the life cycle of a pod works. Okay, so to understand this, when you do a kubectl describe, just above the events log, there is a condition. Now, in that, you will be able to find out that what is the condition of a pod. Now, when I say condition, so typically there are 4 conditions of a pod. Okay, so the first condition is pod scheduled. So what do you mean by pod scheduled? So whenever Kubernetes is able to find a machine and it is assigning the pod to a particular machine, then the state of the pod will be as pod scheduled. Okay. Now, after that only, we know that the image will be downloaded and the container will be created, right? So if the condition of the pod is pod scheduled, then it clearly indicates that the pod has been assigned to a machine and thereafter the container creation step is in process. Okay, so that's where you will know that there was no problem for the pod to get assigned to a machine or there is no resource crunch. Everything is fine. But before we go to the container creation, now this is where again your basics comes in. When you have a pod, there are 2 types of containers that you can have. One is called as main container, the other one is called as init container. So again, you have to go back to your basics and understand. Okay, now this is where when you try to create a pod, the first thing happens is it creates the init container. Okay, once again, it is not mandatory that you should be having init container, because when you learn, most of the people will not say. But you need to know, like I said, the basics. Why do you need an init container and when to use? So I'm not going to cover that here. I'm just trying to give you the explanation of the problems. So that way, assume in your pod, if you are going to have a init container along with your main container, then in the lifecycle policy, first the pod will create the init container, and after completing the init container's execution, it will go to the main container. Okay, so in that case, when the init container is getting started, okay, at that time the condition of the pod will be initialized, which we will see it little later. But now understand, when you see the condition of the pod as initialized, then the meaning of this is your pod is still trying to create and run the init container, not the main container. Okay, because sometimes before even running your main container, there could be a problem in the init container and your pod is getting recreated or stopped. So then when you try to do the kubectl describe the pod, you will get this message, and then you have to understand, okay, problem is not on your main application or main container, problem is on the init container. So what is the image used for init container? You need to find and you need to see the logs and fix it. Okay, so now only when the init containers has successfully completed, the pod will now create the actual main container, which is what so far we were seeing. Okay, so now when the pod has successfully created the main container, then what happens? Now that's where, when the pod is able to run the main container and the health check on that particular container is success, only then the traffic will be sent to the pod. Okay, So I'll repeat this if you are not aware. So when you create a container, this is the main container, and the main container is able to run the whatever the startup script you have. But remember, when you have a health check given on that, only when the first time at least the health check is successfully returning 0, only then the traffic will be sent to the pod. Until that time, the pod will not be used at all. So for example, if you try to create a pod, and if you have a service object or a load balancer and you're trying to access your application, if the health check has not completed at least one execution and it is not returning 0, you will not be able to access your application or the port number, because you can see that the container or the pod will be marked as ready condition only when the health check has been success. So if it is not success, then the pod will never be allowed under your load balancing. So if you try to access, even at that time, you will get a message saying that there is no such port. So that is when immediately you should come back and find out by doing a kubectl describe, has your pod moved to ready state? So this is where, when will the pod move to ready state? Only when the main container has started and the startup command or the application is running fine, and your health check has completed at least one execution and it is giving you success. Okay, so that's another way that you can debug, because sometimes what will happen, deployment will be success, there is no error message, your container is also running, but there is some reason health check is not running. Okay, then when you go ahead as a user and access your port number or the load balancer or the service port, you will not be able to access the application. Then to debug, if you come and say kubectl describe and see if the condition of the pod is not ready, then immediately you should think, okay, so now once again the problem is with the main container, looks like the health check is not running. Okay, so that is how you should find out why it is not running. All right, now if the health check has been successfully executed and it is also returning 0, only then the pod will be marked as ready and the traffic will be sent to this pod, or Kubernetes will allow you to start using this pod only after moving the state to ready. Okay, but due to some resource issue, anytime if the pod is not being able to assign to any machine, then the state of the pod will be unschedulable. But if not, these are the common conditions that you will see. Okay, now let me show you a little deeper understanding of the scene, because now if you say, if you want to create a pod, so assume this is the pod. Now as soon as your pod gets assigned to a machine, the first one that it will run is a init container. Okay, and while init container is running, the condition of your pod will be what? Not yet initialized. Okay, but however, once your init container is successfully completed, then it will try to run the main container. Okay, now in the main container in Kubernetes, you can also have a small script, which is what we call it as post start hook. So as the name says, whenever you are trying to create your main container, along with your startup command or default first command, you can also run another startup script, which will run immediately after the main container is created. Okay, now this is how, after your init container is successfully completed, inside your pod your main container will start running. Now once the main container starts running, you have your health check to be executed, right? But once again, your health check will not immediately run as soon as you start the container. That is the main container. Why? Because you need to give some delay for it. Because logically, if you understand, as soon as my container gets started, if I go and run my health check will fail because application would not have successfully started. So you need to give some time for the application to come up, and then your health check will run. So that is where whenever you are giving a health check command, you should give some initial delay which could be 10 seconds or 30 seconds or 60 seconds, depending on your application. And only then your health check will run. Okay, so that's where you are understanding the life cycle of a pod. So now, once the main container is created and the startup command is running, and after a given seconds, then your health check will run. Once again, in the health check, you would be having a readiness probe and a liveness probe. Okay, so depending on the type of your application, you can give both. But however, if you have a readiness probe, only if the readiness probe has been executed and it is returning a 0, then the state of your pod is marked as ready. And that is where traffic will be sent to it. Okay, so this is what happens in your life cycle of a pod. Now, same way, when you try to delete a pod or stop the container or delete a container, the same way, before directly going ahead and stopping this container and deleting this container, you can also have something called as a pre-stop hook, which can be again a command or a script that you can use to run some command before the container gets stopped. So one common use case for that is you can have some graceful shutdown of your application. Suppose for some reason container is getting crashed or container is being stopped or someone is forcibly stopping or deleting your container. Now immediately you don't want the container to get deleted. So you want to make sure whatever the application that you have inside the main container, it should be gracefully shut down, and then the actual container should get deleted. Okay, so all these things will happen, which is what we call it as pod life cycle. Nowadays in interview, some people might ask you this question. So what is this life cycle? Now you need to understand where is the pod condition, what is happening with it, because if you are getting an error, you should debug based on this, which is very, very important. Okay, so again, quickly, whenever you assign a pod to a machine, first init container will come. And this is where, if you look at the pod condition, it will very clearly say pod scheduled is true, but initialized is false, ready is false. Why? Until it doesn't successfully run the init container, the initialized state will be false. So this indicates now the pod has been scheduled, but still my init container is running. And this is where when the init container completes and your main container is created, then if you look at the condition of the pod, it will show pod scheduled is true, initialize is true. So this is where when you say initialize is true, it means that the init container has been successfully created and it has completed. And then you have created the main container. Okay. However, only when your readiness probe is completed, then if you go and look at the condition of the pod, your ready state will also be true. So that's when, if your pod has an issue, or let's say suddenly your application is not accessible, quickly you should come and first check your pod's condition. If it is in not ready state, that means there is a problem with your health check, and then you have to debug why the application is not running your whatever the commands properly. Okay, so this is what we will see now practically. Okay, so to understand this, so let me go back and first let me delete this. So there's a pod already running, so let me delete. Okay, now to show you the example of pod lifecycle, so I have a YAML file. Okay, now just pay attention here. Okay, because there's a combination of couple of things I have put. So the first thing here is, this is my same test pod where I'm trying to print my name for every 10 seconds. Okay, now along with it, I have also given the health check. So I'm again giving the same condition of the health check, and I'm saying run this after first 30 seconds, and every 5 seconds you should run this. Okay, so this is what we have seen. But in addition to it, now if you look here, I have given the node selector also. So whatever we have seen so far, I'm putting everything together to show you one by one. Okay, so here once again I'm saying this pod should be assigned only to those machines where you have a label called my node and demo node, because if this itself doesn't happen, your pod will not be in a pod scheduled state. So to show you that, I will have, and then further if you see, I'm also adding a init container to this. So pretty much what I'm going to do in this init container is I'm going to simply run a small shell script which will be waiting for 120 seconds. And to show you the example, I'm forcibly stopping it. So let's see what happens when I run. So now when I run this, the first thing it should do is match a machine which has a label. So if this gets matched, then the condition of your pod will be scheduled. Okay. So to see this, what I want you to first do is, let me go back to this. All right. So here, I'll just try to run the same watch command. Okay. So I'm just going to say kubectl. Okay. Now, probably what I will do is, if you want to see the conditions, where is it? So to show that, now let me quickly create a pod and I'll show you where is that state. Okay. So if you say kubectl describe pod and the pod name, okay. So what we were seeing is the event, but just go up. You can see there is something called as condition. And this is where you can see that there are different conditions. So what is initialized? So initialized means your init container has successfully completed. What is ready? Your health check has been success. This pod on container is ready to serve the traffic. Containers ready means your still pod has not created the containers, and once it is successfully created the main container, this state will be there. And pod scheduled means pod was able to assign to a machine, and now it is going ahead with the next step of init container or main container, whatever. So that is how, when you see everything true, it indicates that your pod is completely running fine. Okay, so now let us try to take this and see how it is going to change from the beginning. So to run this example, I'll say watch, all right, and I'll say kubectl describe pod test pod, but I want specifically only the output of the conditions line. So this is where what I will do, I will pipe the output, okay, and I'll try to grep the line called condition so that it will give. But what I want now is, I don't want to just see the line called condition. After the condition line, I need to print whatever the different things we were seeing. So that's the reason I'll use -a. Okay, so this is the basics of your Linux. -a means whatever the line which is matching the string I'm going to give. After that, print me 5 lines. Okay, so now this is the string. So what will happen now is, when I run this from the kubectl describe command, it will try to print me 5 lines after the line called conditions. So that way, whatever I wanted to show, we will be able to see. Okay. You can see right now, it's exactly showing you this 5 lines. Okay, because my current pod is running fine. You can see. Now, this is what we will see as a life cycle. Okay, so let's see one by one. Now, quickly, let me delete this pod. Okay, so there is a pod running. So let me delete, and let us try to run the pod, whatever we have, and see the life cycle. How does it behave? Okay, so just pay attention here. So I'm going to run this one. So in the beginning, when it is able to find a machine with the label, it will say the condition as what? pod scheduled. But if it is not able to find any machine because of a resource issue or a label issue, then accordingly the condition will also be marked as unschedulable. Okay, so we'll try to see that. Okay, let the pod get deleted. Okay, now don't worry about the message because here there is no pod. Now quickly, let me remove the label on the machine so that you will see. So kubectl, okay, I need the machine name. Kubectl label node, and I'm going to again remove the label because yesterday we had added it. So there is no such label here. All right, now let's go ahead and say kubectl apply -f and pod lifecycle. So this is the YAML file which I just showed you. Okay, now here you can see kubectl get pods. So the status is pending. Why it is pending? Because if you do a kubectl describe, it should clearly say that there is no machine available to match the label. And that is where, if you see, what is the state or the condition of the pod? It clearly says pod scheduled is false, because only when it is able to find, it will specify this. Okay, so side by side, what we will also do is, I'll try to do kubectl get pods -watch. So let this also run. Okay, and now what I'll do, I'll take one more command prompt and I'll show you the other states. So for this, let me quickly take it up, the connection string, and I'll open a new command prompt and I'll connect to the machine. Okay, so let's try to see all of that one by one. Okay, so I just have 3 screens to show you. So there is one screen where you can see I'm trying to say kubectl describe and show you the condition, and there is another way where the pod status we are seeing. And now let me apply the label. Okay, so kubectl get nodes. So I will apply the label now. Kubectl label node, and the name of the label is my node equal to demo node. Okay, so as soon as you apply, the pod will get assigned, and that's where you will see the status is changing from pending to container creation. And here exactly the condition, it will say pod scheduled is true, and next it will move to init container execution. Okay, because we have the init container given, right? So that you will be able to see. So watch that. You can see now the state mode, but it didn't go to container creation because container creating state is for main container. Right now I have a init container, and that's where it clearly says there is one init container and it is still running. Unless and until this doesn't complete, you will not see the state moving. And here also you can see that it started saying pod scheduled is true, but only when this init container completes, you will be able to see this is marked as true. And then here the status will go to the main container, which is where container creating will be mentioned. Now, meantime, when it is running, just to quickly show you here, kubectl describe and your pod test pod. So you can see what is it running? It is running a container called as C1. Okay, so what is C1? C1 is nothing but your init container, wherein we are trying to run a simple command called echo. Okay, and now just to show you that, see, if my init container is running, I should get this message. If my main container is running, I should get this message. So this is where, if I just go back, and while this is still running, if I just say kubectl logs -f and test pod, and now I need to get exactly the container C1. So if I run, you can see it's just going to give you stay home, stay safe. So this is what happening on the init container. But only when the init container completes and it moves to the main container, the status will change. Okay, but however, what I have given exit command 1. So after this 120 seconds, what will happen? The main container, will never come up. You can see now the init container got an error. So just like how the pod restarts your main container, if there is an error in the init container will be restarted. So this is how again and again the pod will first try to complete init container, and only then it will go to the main container. Okay. Now, right now it is still failing. Okay, so once again it will try to pull. So what I will do is, let me change it. So for that, first let's delete this. Okay, and let's recreate it from the beginning, wherein this time I will remove the exit one, so that you will see the same. After your init container is completed, you should be able to see that it moves to the main container. Okay, so we'll see that now. So again, this is how you can see the life cycle phases. So from the init, it is directly going into terminating. Now, let's quickly delete and create it again. Okay, so I'll open this YAML. Now, just bear with me. I'm just moving the screen. So here, the exit, I'll just remove it. I don't want exit. But just to show you, I'll just run this in 60 seconds. So as soon as the 60 seconds completes, you will see this will move to the main container, and in the main container your health command will run, but only if this is success you will see the status ready. If not, it will not be there. So let's run that and see. All right, so here kubectl apply -f and pod lifecycle. All right, so if you come back here, the pod has been assigned to a machine and your init container is running, and to cross check, if you say kubectl logs and -f test pod and the first container, so you can see you're still running your init container. So let's wait for 60 seconds and then see what happens to this. So after 60 seconds, the init container will complete, and then it will go to the main container, and that's where your initialized state will be marked as true. Okay.
Actually, I was confused in between describe and logs. So as I understand, describe is to the life cycle of container and pod creation. And log is to if some application is running inside a container, it will show the log of that, right?
Can you please wait for some time? I'll finish this and I'll get back to your questions. Okay. So now if you see here, what has happened? Your init container has completed, and only then it is going ahead with your main container. Okay. And that's where right now, if you see, if I just quickly do a kubectl describe, so the health check is failing, that is expected. But look at the output. Your init container has completed. Now it goes with the main container. Okay. And there health check is failing. Let it be. Let's not worry. But if you come back and see here, do you now see the pod is in a running state, but here you can see initialize is true. But why is it not ready? Because the health check is not success. So only when the health check is success, you will see that the state will be ready and the container is also ready. And only then traffic will be sent to this pod. Okay. Now to get that again, so let me stop everything and redo it. So let me delete the pod quickly. Okay, let it delete. Okay, now quickly what I'll do, let me edit the same YAML file. Okay, so this time I don't want any health check, or simply what I'll do, I'll remove this file. So now when I run health check, definitely I know ls command is there and it'll run fine. Okay, and just to run this also quickly, I'll reduce the time here also. I don't want 60 seconds. Instead, I'll just keep it as 20 seconds. And let's run this. Okay, so let's go ahead and let's watch the screen now. So again, describe is not running. So here I'll say kubectl get pods. And now let's go ahead and say kubectl apply -f and pod lifecycle YAML. So now machine has been assigned, the label is found, and then now it is trying to first create the init container, and you can see it is running the init container. Because of that, the status is init 0. Now as soon as it completes, you will see the initialize is true, then your main container will be running. Okay, now to quickly see that also, let me just say, okay, anyway, it started your main container, and now the main container has become running, and here you can see that initialize is true. But unless and until the first check doesn't go through in your health check, you will see that the container ready state is still false. Okay, so whenever your health check completes, then you should be seeing that this condition moves from ready, which is false, to true. Okay, and you can see now it became true. Okay, so that is because the health check first execution has completed, and that is when you can see it is saying 1 out of 1, and the initialized is true, your ready and container ready is also true. Now only at this level your pod will receive traffic, and that's where you need to understand the life cycle. Okay, because anytime if there is a problem in your liveness probe or readiness probe, then this will not be marked as ready. Okay, now along with this, I also showed you this part, right? So there is a pre-stop hook. So to show you this example, what I have done, I have actually added a life cycle command, which is again you need to learn in your Kubernetes. Now in this, what I'm doing, I'm just trying to put a small pre-stop command, put for sleep of 30 seconds, because again I don't have any application running, so I cannot show you that. But instead, now when I try to stop my container or delete my container, container will not get deleted immediately. It will try to run this pre-stop command, which is nothing but 30 seconds. So you will see that even after entering my kubectl delete pod, you will see that there is a 30 seconds gap, which is nothing because this pre-stop command is getting executed and there is a sleep of 30 seconds. And after this, your actual pod or the container will get deleted. Okay, so let's look at all the status together now. So pay attention here. What happens? So kubectl delete -f pod lifecycle. So you have received, that's the pod receives the terminating, but still you can see it is running. Why? The pre-stop command or lifecycle command is running. So that is running for 30 seconds, right? So until then you can see the pod will still receive the traffic because you're trying to do a graceful shutdown. But after that pre-stop command is completed, then the pod will first mark as not ready. Okay, so that is where you should immediately, if you monitor this in a fraction of a second, these two will become false. Do you see that? Then it stops the pod. Okay, so that is how, before deleting, what first it will do is it will mark the pod as not ready, and then it will be deleting the pod. Because if not, what will happen? There might be already a traffic coming to it, so that shouldn't get stopped. So that's the reason first it will try to say stopped, okay, by making sure that the pod doesn't receive any more traffic, and then it goes ahead and deletes everything. All right, so that's what the life cycle happens. Okay, so just like how you create a pod, there are conditions. The same way, when you try to stop your pod or delete your pod, the container doesn't get deleted. First, it will try to run the pre-stop, and here it will make sure that if you have a graceful shutdown, that will run, and only after that the main container will go ahead and get deleted. Okay, so this is exactly where you also need to understand what are the different conditions of your pod. Okay, because going forward, now anytime if you get an error, you need to understand and try to debug. Okay, so for all these things, you need to know the status of the pod, and you also need to know the condition.